Okay, to do this first problem, we have to remember that rule that y equals log base a of x is the same thing as a to the y power equals x. So they have this in the a to the y power equals x form. So translate it to the log form. We have 4 is in the y spot equals log a is 10 of x, which is 10,000. And now when we're doing log base 10, we don't have to write the base there. That's implied. So if there is no base written, it's implied it's base 10. Okay, so we're doing the opposite on this one. They gave us log base 7. So here's a, and here's our x, and here's our y. So this is the same thing as 7 to the second power equals 49. I don't know if this is something that helps you remember this, but we would say this as log base 7. So the base of our exponent is 7, right? So base means the same thing in both places. And for number 3, it's 100 is the base to the third power equals 1,000,000. Number 4, this says 4 to the x power equals 64. So we're trying to find out what that number is. 4 to what power equals 64? That's 4 to the third power equals 64. So x must equal 3. 5 to the negative third power equals x. So I just have to figure out what 5 to the negative third power is. I'm going to remember that's 1 over 5 to the third power. 5 to the third power is 125. So 1 over 125 equals x. That's my answer for the second one. Last one on this page, x to the 1/2 power equals 2. To solve this one, I'm going to square this side and square this side. So I'm trying to make this x to the first power. I want just x to the 1 equals 4. So really that just means x equals 4. Number 7, when I have 5 to the power of log base 5, the answer is just that 6. Okay, when we have this set up where the base of my exponent and the base of my log are the same, the answer is just what I was taking the log of. Okay. Log base 6 of 1, log base anything of 1 is 0, because 6 to some power, okay, this is what we're trying to figure out, 6 to what power equals 1? To raise 6 to a power and get 1, x would have to equal 0. Ln, that's an L, and an N, that is the natural log. Natural log and the exponential function cancel each other out. So the answer is just 5 to the 4th. Okay. This, when it says common log, that means we're talking about log base 10. It's the log that your calculator does. So if in your calculator you type in log of 2, it will tell you this answer when you round to 4 decimal places. Okay, this is a button on your calculator. You're just going to type in ln of 66, the natural log of 66, and you will get this number. Number 12, it says, find the pH for a substance with the hydronium ion concentration of 4.1 times 10 to the negative 4th power. And they are forgetting to tell you that to find this, we need to take the negative log of 4.1 times 10 to the negative 4th power. Okay? And in all honesty, you can just type that whole thing in your calculator, right? Type the negative sign and then log and make sure all of this is in parentheses, and you'll get 3.4. On our next problem, they're telling us what the pH equals. Okay, they're telling us this part of the equation. So we get 3.6 equals negative log of something. That's what we're trying to figure out. Okay, so I'm going to divide both sides by negative 1. I get negative 3.6 equals the log of x. Remember that if it didn't tell me the base is implied to be 10. Okay, because we have a base 10 number system. So now I'm going to rewrite this as 10 is our base to the negative 3.6 power equals that x. Okay, I'm just doing like what we did in the very beginning of this assignment. 10 to the this power equals x. If I type in 10 to the negative 3.6 power in my calculator, I get 0.0002511188. Okay, keeps going. So that would be 2.5 times 10 to the 1, 2, 3, 4th power to get that to that spot. Okay, but this is a little number, so it's times 10 to the negative 4th. If this number was bigger than 1, that would be a positive power. This is a little number, so it's a negative power. Same exact process for this next one. 3.5 equals negative log of x. So negative 3.5 equals the log of x, implied that it's base 10. So 10 to the negative 3.5 power equals x. When I type in 10 to the negative 3.5 power into my calculator, I get 0.00316. Okay, it keeps going. So that is 3. This 6 is going to round that 1 up to a 2 times 10, 1, 2, 3, 4th power. This is a little number, so it would be negative 4th. Okay, number 15, I'm rewriting using the properties of logarithms. Remember that multiplying gets rewritten as adding, dividing gets rewritten as subtracting. So we have log base 4 of 7. That 7 got multiplied by the y, so it's plus log base 4 of y. And we're dividing by that z, so it's minus log base 4 of z. Number 16, we have log base b of x and log base b of y squared and log base b of z to the fifth. X and y squared would be multiplying, z would be subtracting. Now we're going to go ahead and deal with these exponents. Remember that an exponent can be moved to the front. So now I have log base b of x plus 2 log base b of y minus 5 log base b of z. Number 17, I'm going the other way. So this 2 goes here and the 4 goes there. So now I've got log base a of x squared minus log base a of y to the third to the fourth, which is just to the 12th power. Subtracting gets rewritten as dividing, so log base a of x squared over y to the 12th. Because the log base a is the same for both. Okay. So this 2 moves to be an exponent. So I have log base a of z plus 1 squared plus log base a of 3z plus 3 it's the same base on both, and I'm adding, so that can be rewritten as log base a, and then everything else is just multiplied. Z plus 1 squared times 3z plus 3. Number 19, the laws for logs work for natural logs also. So these are exponents. So now I have the natural log of x squared minus the natural log of y to the fifth. Subtracting gets rewritten as division, so it's the natural log of x squared over y to the fifth. Okay, remember the change of base rule is just the log of 30 divided by the log of the base, so log of 2. And let's just type it in your calculator, see what you get. The last one would be log of 3 divided by the log of 32. Type it in your calculator, see what you get. Okay, good luck.